My name is Denis Kraseninkov. I am a research developer in the personalization team at Tinkoff Bank, and my area of work is recommender systems. And today I'm going to tell you about our work on using crowdsourcing for recommendation explanations. So why do we need explanations to recommendations at all? According to the research shown on the slide, the explained recommendation increases the user's trust in the service. Because of the increased trust, users interact with the service more actively. They generate more data for us. This all leads to model quality increasing. We now have more data for each user, hence we can generate recommendations more accurate for them. In our work, we used item-based explanation format. Since you recently made a purchase from merchant X, we suggest you merchant Y. For now, merchant is a shop or cafe or restaurant, etc. We've chosen such one for several reasons. Firstly, it is easy to generate pairs for markup. We randomly sampled 2 different merchants. Secondly, for any merchant, there is almost always another merchant through which it can be explained. The disadvantage of this format, however, is that it doesn't provide detailed explanations because it only represents one merchant and doesn't take into account the interaction with 2 or more. All of my further story will focus on how to generate an explanation that merchant Y and assess the quality of those explanations. Considering an example, we recommend you to go to a coffee house because, and then we have a list of candidates from the user's previous transactions to sort by relevance. However, there is no way to get such data from the original dataset. To solve this problem, we need someone to mark whether one shop is relevant to another. Ideally, we want a real value, but a binary yes or no will work too. One of the solutions to this problem is A/B test, but we don't want to show some illogical explanation like we recommend you to go to a coffee house because you bought in the hardware store. Such a weird explanation could scare away customers and ruin company's reputation. Moreover, such A/B test would be last a very long time. And that's why we use crowdsourcing. Now let's talk about the data. In our work, we used open source TTRS dataset, which is available on request. This dataset contains anonymized user transactions. Each row represents user ID, item ID, timestamp of the transaction, and other metadata like category of the merchant, etc. For now, we will omit everything except user ID, item ID, and timestamp. We left only last user item pair and transformed dataset into n users m items matrix. 1 in the cell if user had transaction in the merchant and 0 otherwise. Timestamp was used for train validation test split. As a recommendation system, we used alternating least squares model. We used internal crowdsourcing platform to mark up the data. Beforehand, we reduced the number of merchants, leaving only the popular ones. We took the most popular 350 merchants, which covered almost all transactions. This was done in order to minimize the number of cases when assessors came across merchants that they didn't know about and therefore couldn't evaluate it correctly. The full operator assignment is shown on the slide. Before marking up, the operators were put into the context. Let's say you made a purchase at merchant X, then you see the following recommendation. Since you recently made a purchase from merchant X, we suggest you merchant Y. The operator's task was to answer whether this recommendation is correct or not. If they say that the recommendation is correct, then we consider merchant Y because merchant X is good explanation. From the remaining 350 merchants, we randomly generated 23,000 such pairs. Note that X because Y doesn't mean Y because X. To make the data objective, each pair was tagged by 5 different people. In total, about 400 operators were involved. Let's look at the algorithm for our work. First, we train our recommender system. Next, for each user, we create any recommendations. Now, for each recommendation, we need to generate an explanation using the merchants from the user transaction history. Since we only generated 20% of all possible pairs, we remove those explanations for which we have no markup. And the last step is to calculate the metrics of our explanation. Let's discuss this point in a little more details. Going back to our example, let's say the assessor marked up the candidates as follows, where 0 is the pair they didn't get, 1 means they said that the recommendation of merchant X because merchant Y is correct, and -1 otherwise. Then we want to get the following results. All the merchants that assessor has marked up as relevant, we want to rise as high as possible in the top. In this case, as close of the beginning of the list as possible. And we want to push those that the assessor has marked up as irrelevant to the end of the list. In fact, we come to the task of ranking, so we'll use ranking metrics. As I already said, generating explanations in our case means to order previous user purchases according to some rule. We consider the followings. Random order, it is used to compare with the other methods. In fact, it is a measure of adequacy. Some heuristic rules like ordering by general population of merchants, ordering by personal popularity, ordering by chronology, newer equals better, associative rules, algorithms that look for relationships between two items based on their co-occurrences. Same categories sorted by popularity. As you may remember, I said that every merchant has a category. So if we recommend a merchant from category A, we first explain through objects from the same category, ordering them by popularity, and then add the rest in the general order. We also use some machine learning methods like is, ILS is the model that generate recommendations, and some categories sorted by ALS, similar to previous method but now with ALS scores. Machine learning methods can be seen as black boxes. They learn some relationships between items in the training process, which we then use to generate explanations. So results you can see on the slide. This is the metrics of the explanation quality. We looked at IndCG at K, recall at K, and NAP at K. AR with index are different methods of associative rules. SimCat most pop, same category sorted by popularity. SimCat ALS, same category sorted by ALS. And as we can see, the best explanation generated is pure ALS. Also, we got some interesting results, like explanation quality of is not good enough, or SimCat ALS performed worse than pure ALS. This is most likely caused by different price ranges with the same category. So takeaways. Crowdsourcing helps us to mark up the data without unnecessary difficulties. We introduced new approach to evaluating the quality of the explanation of recommendations. Heuristic methods showed quite low metrics, and alternatively squares showed good metrics relatively to other methods. As for the future work of this paper, there are three main area of focus. First, consider more complicated methods of constructing explanations to improve their quality. Secondly, to change the format of the explanation itself. In 2023, few people will be surprised by such a simple format X because Y. Third, the problem of this method is that we considered only the popular merchants. However, we need to recommend all merchants, hence we need two explanations for all merchants. At the end, I want to say thank you to my colleagues from Tinkoff AI Center with whom we did this work. You can see their names and contacts on the slide. That's all I have for today. Thank you for your attention. If you have any questions, do not hesitate to contact me.
Thank you very much for so structured presentation. And we have one question.
Thanks for the talk. That was quite interesting and a very nice use of slides as well. Very attractive. My question to you is about whether you've explored the notion of interactive explanations. Because I understand you've been trying to optimize the nature of explanations that you're generating and the metrics that you've looked at. I wonder whether, in your ongoing work or in your exploration so far, you've been thinking about interactive explanations where, the end user who's consuming it can actually contribute to the iterative way of generating an explanation.
Yes, I think it is one of the future works because such format is, I think, hard to measure with crowdsourcing. So we need real users experience, and I consider it's like one area of future works.
Thank you. I also have a short question. What crowdsourcing platform have you used?
We used internal bank crowdsourcing platform with real operators.